So far, we've used Ask for writing proofs, but Ask also contains a programming language, which you'll be learning about this week. Then in the next 2 weeks, we'll be joining everything together and writing proofs about our programs. In order to write programs, and also in order to prove things about anything other than propositional variables, we need data types. Ask doesn't have any built-in data types, but it does have a mechanism that you can use to define your own, and that's what this video is about. The mechanism for defining data types in Ask is almost exactly the same as in Haskell, and it's also extremely closely related to BNF grammars, which you learnt about last semester. So here's an example of a data type definition in Ask. It begins with the keyword data, followed by the name of the type that we're defining, which has to begin with a capital letter, and then the equals symbol. And after that, we have a list of things called constructors, which are ways of building values of our type. So here we have 2 constructors, which means that this data type contains exactly 2 values. So this kind of thing is normally called an enum type in programming. Here's a much more interesting data type. I'm going to define a recursive data type, which John showed you last semester. I can define the type of natural numbers like this: data, nat, equals, and then I say a natural number is either 0 or it's the successor of a natural number. So this data type has 2 constructors. It has 0, which takes no parameters, and it has suck, the successor constructor, which takes 1 parameter, which is another natural number. So in a data declaration, every constructor is followed by a list of 0 or more parameters that constructor should take. Okay, let me show you what values of type nat look like. So these are natural numbers written with a unary encoding. So we have 0, which is 0, and then we have suck 0, the successor of 0, which is better known as 1, and then we have suck 0, the successor of 0, which is better known as 2, and so on. Okay, here's another example of a data type. Lists of natural numbers. So here is one way of defining lists. A list is either the empty list or it's a natural number joined onto the front of another list. So we're going to build lists by starting with the empty list and joining elements onto it one by one, going backwards. So the traditional name for the list building operation is cons. So I'm going to write data nat list equals empty, or cons nat list. So cons here is the traditional name for the list constructor, which is in fact short for construct. So let's see what values of nat list look like. Let's say we want to build the list 2, 1, 0. So we're going to start from the empty list, and then we're going to work backwards. So we're going to cons 0 onto it, and then working backwards, we're going to take that and we're going to cons 1 onto that. And 1 is written suck 0. And then we're going to take that and we're going to cons 2 onto it. And cons is written suck 0, like that. So you can see that in principle, we could write any list of natural numbers like that, but it's totally impractical to actually use. Another feature of data declarations in Ask is that we can give names to parameters of a constructor. So I can change the definition of natural numbers to say successor of a natural number, which is called n. So to do this, I use this double colon symbol where the name of the parameter goes before it and its type goes after it. And also in natlist, I can give the 2 parameters of cons their traditional names, which are head and tail, like this. So if you have a non-empty list, then head refers to the first element and tail refers to the list of everything other than the first element. Okay, the next feature is that we can make a parameterized data type. So we wrote lists of natural numbers, but we can actually make a single data declaration to make lists of anything. So what we do is, after the name of the data type, I can write some parameters, and that parameter means any data type. And now I can use that parameter in the definition. So I can write a list of A's is empty, or it's cons with an A and a list of A's. Okay, so if you know about Java generics, then this is exactly like Java generics. So now instead of writing nat list, I can write list nat. Okay, I should also mention that a data type can have as many parameters as you like. So I can make a data type for pairs like this. I can write data pair with 2 parameters, A and B, and then give a name of a constructor like make pair followed by those 2 parameters. And now, for example, pair nat is the data type whose values are pairs of natural numbers. Or I could say pair nat list nat. This is the data type of pairs where the first thing in the pair is a natural number and the second thing in the pair is a list of natural numbers. And you can actually use this thing as a representation of non-empty lists. Okay, there's one last data type that I want to show you because we're going to be using it as a running example for the next few weeks, which is binary trees with labeled nodes. So a binary tree with some data parameter is either a leaf or it's a node together with a left subtree and a piece of data which I'll call the key, which has type A, our parameter, and a right subtree. You can think a bit about what values of this data type look like. Okay, in the next video, I will be showing you how to write programs that interact with the data types that you've defined.